So I'm making this video to help you out with a few of the problems on your 8-6 review worksheet. So I've picked about, I think 5 or 6 of them to go over with you. First one I want to do is number 9. So we need to get the fractions eliminated. So the lowest common denominator here is x plus 4 times x plus 10. So we're going to multiply each side of the equation by those factors, x plus 4 times x plus 10. We need to multiply everything by the same factors, okay? I can't choose to multiply this fraction by x plus 4 and this fraction by x plus 10. You need to include both of them so that we're multiplying both sides by the same thing. Okay, so now let's do our canceling. On the left, the x plus 4's cancel out, and what I have is x plus 10 times x minus 2. Make sure you write those in parentheses. We're going to have to use FOIL there. On the right side of the equal sign, the x plus 10's cancel out, and we have x plus 1 times x plus 4. Okay, now we're set up and we're ready to FOIL, so let's go ahead and do that. We get x squared minus 2x plus 10x minus 20 equals x squared plus 4x plus 1x plus 4. Okay, now we can solve our equation here and combine like terms. So the one thing that I'm noticing right off the bat is that the x squareds on each side can cancel out. If you subtract x squared from each side, they're gone. So now let's combine our x's. I have 8x minus 20 equals 5x plus 4. Let's subtract 5x on each side. Let's add 20 on each side. And what I have is 3x equals 24. So if you divide each side by 3, x equals 8. Now check to make sure it works. We have 6 over 12. Is that equal to 9 over 18? Yes, each side equals 1/2. The next one I want to do with you is number 10. This is an inequality, so we have to first say the value of k that is undefined. Well, k cannot equal 0 because I can't have a denominator of 0, so we'll start there. Now let's solve the related equation. 3 over k minus 4 over 3k equals 0. Well, the common denominator here is 3k, so I'm going to multiply everything by 3k. Okay, so when I do that, in the first fraction, the k's cancel out, and 3 times 3 is 9. Minus, in the second fraction, 3k cancels out, and I have 4. And then I have equals 0 times 3k is 0. Well, we know that 5 does not equal 0, and so I'm not really going to get a solution here. Let's draw our number line and see if we can find values on the number line that will work. So the only point I can really put on my number line is 0. I know k cannot equal 0, so that value's out. We'll put an open dot there to say we can't have a 0. I need to check points to the left of 0, like -1. And points to the right of 0, like +1. So let's just check those in the equation real quick here, or in the inequality. So I'm going to plug in -1 for k. So 3 over -1 minus 4 over 3 times -1. Is that greater than 0? Question mark. Well, 3 over -1 is -3. The two negatives here will make plus 4/3. Is that greater than 0? Well, this is -3 plus 1 1/3. It's going to be a negative number. So is it greater than 0? No. So -1 is out and everything to the left of 0 is out. Let's test +1. Plugging in +1 for k. 3 over 1 minus 4 over 3 times 1. Is that greater than 0? Well, I have 3 minus 4/3. Is that greater than 0? Well, this is 3 minus 1 1/3. So 3 minus 1 is 2. And if I subtract another 1/3, I'm left with 1 2/3. Is that greater than 0? Yes. All right, so everything, not including 0, but everything to the right of 0 is a solution here. So you could say k is greater than 0, or you could use interval notation and say 0 to infinity. The next one I want to do with you is number 12. We have an inequality again, so your first step is to state the excluded value. N cannot be 0 because if you plug in 0, your fractions are undefined. Now let's solve the related equation. N plus 3 over n equals 12 over n. I'm going to multiply everything by n to cancel out my fractions. So n times n is n squared plus, in the fraction here, the n's will cancel out, so I just have 3. On the right side of the equal sign, the n's cancel out, and I get 12. Now I'm going to subtract 3 on each side, and I get n squared equals 9. Well, I'll take the square root of each side, and n equals plus or minus 3. Okay, now let's make our number line. On the number line, I actually need to include 3 values this time. I need to include the -3, the +3, and of course 0. So now I actually have to test 4 numbers here. I have to test something to the left, so I'm going to pick -4. Something in between, I'm going to pick -1. Something in between here, I'm going to pick +1. And something to the right of 3, I'm going to pick +4. Okay, so let's test -4 first. -4 plus 3 over -4, is that less than 12 over -4? Well, I have -4 minus 3/4, -4 and 3/4. Is that less than -3? Yeah, it is. It's a bigger negative number, so that means it's to the left on the number line. So yes, this is a solution. I'm going to use an open dot on my endpoints here because I don't see an equal sign underneath the inequality. So everything to the left of 3 is a solution because -4 worked. Let's check -1. So I'm going to plug in -1 for each n. -1 plus 3 over -1, is that less than 12 over -1? Well, what I have here is -1 plus -3, that's -4. Is -4 less than -12? Actually, it's to the right of the number line, so your answer is no. So -1's out, and that means everything in between -3 and 0 is out. Let's check +1. +1 plus 3 over 1, is that less than 12 over 1? Well, I have 1 plus 3 or 4, is 4 less than 12? Yeah. So that tells me that +1 and everything in between 0 and 3 is a solution. We're using open dots here because we can't be equal to our endpoints, 0 or 3, but these all work. I need to stop because I'm just in this interval right now. Now I'm going to plug in 4 and see if 4 works. So I have 4 plus 3/4, is that less than 12 over 4? Well, 4 plus 3/4, that's 4 and 3/4, or 4.75. Is that less than 12 over 4 is 3? The answer is no, it's not. So 4 is out, and now you can see where our solutions are. So finally, we're going to write our answer using the variable n. Look at the graph. N is less than -3 in the first part. Or we could say that n is in between 0 and +3. This gives you all the solutions to this inequality. Next one I want to do with you from your worksheet is number 16. Okay, so we've got 2 fractions, but we've also got this whole number 4. So what we need to do is cancel out the fractions. The common denominator here is b plus 1 times b minus 1. So that's what I'm going to multiply everything by. And I'm going to try to sneak it in here. So this is 4 times b plus 1 times b minus 1. And the first fraction, b plus 1 times b minus 1. Okay, so every term gets multiplied by the same thing. Now let's do our canceling. In the first fraction, the b plus 1 cancels out. And I have b minus 1 times 3b minus 2. We're multiplying a binomial times a binomial. It's equal to, then I have 4 times b plus 1 times b minus 1. We got to multiply all that out. Minus, in this last fraction, the b minus 1's cancel out, and I have b plus 2 times b plus 1. Okay, so we're going to be doing a lot of algebra here, a lot of multiplying. On the left side of my equal sign, let's go ahead and FOIL this out. We get 3b squared minus 2b minus 3b plus 2. Here I'm going to multiply or FOIL the b plus 1 times the b minus 1, and then at the end I'll multiply it by 4. So I get b squared minus b plus b minus 1 minus, now we're subtracting this whole thing here, so when I FOIL this out I'm going to leave it in parentheses because we're going to have to distribute that negative sign. So I have a b squared plus b plus 2b plus 2. Okay, next step. I'm going to combine like terms and just kind of continue doing some simplifying here. I have a 3b squared minus 5b plus 2 equals, the b's here cancel out, so I'm going to distribute the 4 to the b squared and the 4 to the negative 1. So I get 4b squared minus 4 minus, now what I have here is a b squared minus a b minus a 2b minus a 2. That negative sign's got to distribute to everything in the parentheses. Okay, so I'm going to combine like terms on the right and then we'll be ready to solve. 3b squared minus 5b plus 2 equals 4b squared minus 1b squared gives me 3b squared. Negative b and negative 2b gives me minus 3b. And negative 4 and negative 2 gives me minus 6. Okay, now I'm ready to solve. So I notice that the 3b squareds will cancel each other out on each side, and I'm going to start by adding 3b to each side. Negative 5 plus 3 is negative 2b. So I have negative 2b plus 2 equals negative 6. Subtract 2 on each side. Negative 2b equals negative 8. Divide each side by negative 2 and we get b equals 4. Can we plug it in? Yes, we certainly can. It doesn't make either denominator 0. That was a lot of algebra, which is why I wanted to include it in this video. Okay, I've got a couple more to show you. The next one is number 20. Take a look at your denominators here. You have a w plus 2, a w minus 2, and then notice this one's a difference of 2 squares. So if you factor it, you get w minus 2 and w plus 2. That's your common denominator here. That's where we're going to multiply everything by. So I'm going to multiply each fraction by w minus 2, w plus 2, and it's going to cancel out every fraction. W minus 2, w plus 2. You got to squeeze these in really small. Okay, let's do our canceling. So in the first fraction, the w plus 2's cancel out, and I have 1 times w minus 2. Plus, in the second fraction, the w minus 2's cancel out, and I have 1 times w plus 2. On the right side, both factors will cancel out, so we just have 4. Okay, now this is pretty simple to solve. Negative 2 and positive 2 cancel out. I have w plus w, which makes 2w. So 2w equals 4, w equals 2. Now, what's wrong with this answer? Well, if I think about plugging it in, it kind of, okay, so there's a problem because if I plug in 2 to this fraction, 2 minus 2 gives me 0. If I plug in 2 to this fraction, also gives me 0. So I can't have fractions that are undefined. So we actually don't have a solution here. No solution. We got 2, we did all of our math correctly, but when you plug it back in, it doesn't really work because you end up with undefined fractions. So no solution to this one. Watch out for those. It's going to happen at least one more time on your worksheet. Okay, last one I'm going to do with you is 22. This one involves some factoring as well, so let's take a look at this trinomial. Can I find 2 factors of 12 that add up to 7? Well, I certainly can. It would be 3 and 4, so we can break it down into s plus 3 times s plus 4. And notice now, if we multiply everything by those 2 factors, we're going to cancel out our fractions. So I'm going to multiply by s plus 3 times s plus 4. Same thing here, s plus 3 times s plus 4. And same thing over here. Okay, let's cancel these out. So in the first fraction, both factors will cancel out, and you're left with just the numerator, 12s plus 19. And we're subtracting. The s plus 3's will cancel out, and you have a 3 times s plus 4 equals, in this last fraction, s plus 4's cancel out, and you have a 5 times s plus 3. Okay, now let's do our simplifying. So we have 12s plus 19. We're going to distribute here. Minus 3s minus 12 equals 5s plus 15. Okay, combine like terms. So I've got 12 minus 3s. That gives me 9s. 19 minus 12 gives me positive 7. Now I'm ready to solve. Oh, switch colors on me. Okay, that's cool. All right, so we have, let's take away 5s on each side. Those cancel. 9 minus 5 is 4s plus 7 equals 15. Let's take away 7 on each side. 4s equals 8, and divide each side by 4s equals 2. Can I plug in 2 to each fraction? Sure. Okay, so hopefully that gives you a nice head start on your worksheet. I know it's going to take you some time to do these, so use some time over the weekend to figure these out. I did leave a key as well in class, so you can check your answers with the key too.